This is homework set 37 on properties of logarithms. Question 1, what we're going to do is we're going to take this log base 5 of 8x. I'm going to write that down. Log base 5 of 8x. And then what we're going to do is we're going to use the properties of logarithms to find the values of a and b. Now, here's what we have. We have a product. And right below multiplication is addition. So I know I can add these together, getting log base 5 of 8 plus log base 5 of x. Now, if you match things up here, log base 5 of a, so the a is going to be an 8, and then log base 5 of b is going to be x. So let's fill those in. This is going to be 8, this is going to be x. Question 2, let's expand this log base 5 of 6 over x. I'll write it bigger. Log base 5 of 6 over x. We'll expand it using the properties of logarithms, and that will help us to find a and b. A and b being those arguments. So let's do this. This is going to become the log base 5 of the numerator minus the log base 5 of the denominator. Now here's how I did that. This is a division. What operation's right below division? Subtraction. Now I can see that, back up in here, what is a? Well, a is the argument of the first, the top, and b, that comes after the subtraction, so that's going to be a and b. So a is the 6, and x is the b. Question 3, we're going to rewrite this using properties of logarithms so that we can determine the values of a and b. All right, let me rewrite that. So it's going to be the log base 2 of x to the 9th. Now, I know what I can do with logarithms. According to the property, if I have an exponent, I can bring that down in front as a multiplier. So this I can write as 9 log base 2 of x. And now I can see a, that's that multiplier, that's a 9. And b, that's the argument, that's an x. So what I'm going to get here is a 9 and an x. Question 4, let's rewrite this. So here's what I've got to begin with. It is the log base 5. Now instead of the cube root of x, I'm going to write that as x to the 1/3. Right? We don't have any properties of exponents that have radicals in them, so get rid of the radical and use a fractional exponent. Now, this, I can bring the 1/3 down as a multiplier, so I get 1/3 log base 5 of x, and now I can see a is 1/3, b is x. So a is the 1/3 and b is the x, right? A is the multiplier, 1/3, and b is the argument. Now here in question 5, we're going to do the same thing again. We're going to expand that. Now, first of all, can you even see what it is? Looks to me like it's the log base 5 of the 5th root of x. Okay, so I'm going to rewrite this now like this. The log base 5, get rid of the radical and use a fractional exponent to the 1/5, if that's what it is. Now, I can bring that exponent down in front by the properties of logarithm. So this is going to become 1/5 log base 5 of x. Now, a is the multiplier. You can see up here. A is the multiplier. B is the argument. So we're going to get a is 1/5 and b is the argument, which is x. Number 6, let's rewrite this logarithm without the radical. So I'm going to write it as the log base 2 of, now it looks like we've got the cube root of x and then a y to the 4th out of that radical. So first up, get rid of this radical, convert it to a fractional exponent. So we'll get the log base 2 of x to the 1/3 y to the 4th, and now I've got a product. So products become additions, right? What is the operation just below multiplication? It's addition. So let's add these together. So I'll get the log base 2 of x to the 1/3 plus log base 2 of y to the 4th. Now I can eliminate these exponents by bringing them down in front as multipliers. So we will get 1/3 log base 2 of x plus 4 log base 2 of y. Now let's identify A, B, C, and D. So A, that's the first multiplier, that's 1/3. B is the first argument, that's the x. C is that second multiplier, that's a 4. And D, that's the second argument, which is a y. So let's write those in. So we'll get 1/3 x, 4, and y. Question 7, we've got a division here. And divisions, I know I get a minus sign. So here's what I see. Matter of fact, it's kind of a giveaway here, right? They have a minus sign right here. Anyway, here's what I do. When I see a logarithmic expression, if I see a fraction bar, I know I've got a minus, because what I get is the log of the top minus the log of the bottom. So whatever is on top, that's going to be positives. Okay, that's going to be a positive and a positive. And whatever follows the division sign, whatever on the bottom, that becomes the minus. So let's expand this. So I'll just do it all at once here. So this is going to be the log base 6 of 4x minus the log of y base 6. Now, this is a multiplication, so stretch that out. I'll get the log base 6 of 4 plus the log base 6 of x minus the log base 6 of y. And now, A, B, C, D. Well, A, all right, now what is A here? According to this is the first argument. That's going to be a 4. B is the second argument. That's an x. And C, that's the third argument. That's a y. So we're going to have 4x and y. Question 8, what we've got again is a division, just like in number 7. I've got a division, but I got two variables below the division sign, so I'm going to get two minuses. So I'm just going to expand this out directly. So this is going to be, matter of fact, I'll do it right here. This is going to be the log base 3 of the top, and then minus the log base 3 of the x, and then minus, because it's still, the y is still on the bottom, log base 3 of y. Now, A is the first argument, B is the second, C is the third. So we're going to have 4, x, and y. All right, so let's put those in. We'll get 4, x, and y. Question 9, we need to expand this. Now, here's what I know. I have a division, so I know I'm going to get a minus. There's two factors in the denominator, so I'm going to get a minus and then a minus. The exponents, those come down as multipliers. So on the top, I've got two factors, a 25 and an x squared. I'll get a plus between those. On the bottom, I'll get a minus in front of those. So let's just do this. And those exponents come down as multipliers. So this is going to be log base A of 25 plus, now bring that exponent down as a multiplier, 2 log base A of x. So what I did here is that up here at the top, that 2 right there, that 2 came down as a multiplier. Same thing's going to happen with this 4. All right, now go to the bottom. It's 9's in the denominator, so minus log base A of 9, and then A to the 4th is in the denominator, so minus. Now bring that 4 down as a multiplier, log base A of A. Oh, that's interesting. Now, apparently we can go a little bit further here. Here's what I'm going to do. Log base A, now 25 is 5 squared, plus 2 times log base A of x, minus log base A of 3 squared, minus 4 log base A of A. Now, bring this 2 down in front, and bring that 2 down in front as a multiplier. So how about 2 log base A of 5 plus 2 log base A of x minus 2, bring that exponent down, log base A of 3 minus 4 log base A of A. Now here's what we have. A, B, C, D. So I think we can just read these right from down here. Right from down here. Just read them as you go. So A is going to be a 2. And then what is B? Now B is over here. B, all right, B is the first argument. That's going to be a 5. So I'll put a 5 here. And then C, well, C is that, what is C? C is that next multiplier. That's a 2. And D, all right, what is D? D is that second argument, which is an X. All right, so I'll put an X here. And then E is that first, third multiplier. That's going to be a 2. And F, all right, F, where's F? Right there. F is that fourth argument. The fourth argument is that 3. So I'll put a 3 here. Then G is that last multiplier, which is 4. Now, this last one is debatable to me. This right here, this log base A of A, all right, really, that should be a 1. What power would you raise A to get A? Well, you'd raise it to the first power, all right? But that's not how the answer book is doing it, because these are computer generated, so they could have any number in there. So what I'm going to put here is an A. Right now, that A matches this one right here. Question 10. Now we've got a expanded logarithm statement. Let's put it back together. Now, we know those multipliers come up as exponents, right? If it was an exponent, we bring it down. So just undo that, bring it up, and I have a minus. Now, as soon as I see a minus, I'm thinking of division. And whatever comes after the minus, that's what goes on the bottom. So how about this? One single logarithm, log base B. Now, I got a minus in there, so fraction bar. All the positives go on top, so it's going to be x to the 5th. Remember, that multiplier comes up as the exponent. And then on the bottom, we've got y, and then bring that 2 up, y squared. That's it right there. Now, I notice that the textbook is already giving us the log statement in there, so we just have to put that in. And that ends our first set of problems on homework set 37, Properties of Logarithms.